Okay. That's not what we want.
I have to leave 20 minutes early because my mom's picking me up.
Try that a different way.
Oh, is it okay if I leave 20 minutes early today for my mom to pick me up?
Should be all right. Yeah. Okay. So first thing we're going to do is look at. We're going to loop back to this list node problem. Swap nodes in pairs. Because what we had on the board and what I had in code weren't quite lining up, and there was still a little bit of an issue, right? So the code we had on the board had one mistake in it. Did anyone catch what that was? Or did anyone try and run it through IntelliJ? So the first part of our code worked, this whole up to our while loop, right? So we swapped our first two nodes just fine. We had a sentinel pointing to the first thing we were going to return, so that was good. There was something in this next part after our while loop that wasn't quite working, right? Anyone catch what it was? Or did people get this to work?
I got it to work, but after trying your way,
yep.
I didn't figure it out.
You couldn't figure it out?
Yeah.
Okay. And I can't remember, I'll be honest, because I fixed it, and I think I meant to not fix it in one place, but I think I fixed it in both places. So let's just do this and come down here. So I can't remember what we had. Who's got the code that we had on the board? Okay, do you mind sharing your screen for a second? So let's just do this and figure out the piece. Actually, we'll do it right on here. And we'll do it with some nodes. I even took a picture of the chicken scratch that I used to draw my picture out.
The chicken scratch?
My chicken scratch. Never heard that expression before?
Like bad handwriting?
Yeah, very bad. I had it. All right, 5. Okay. Ooh, tiny. Okay. Oh, do you have it in IntelliJ or no?
No. I can actually just copy it.
Yeah, but then you need to do the whole class. Did anyone else have it built out in IntelliJ? Actually, just leave it right there. Leave it right there, and we'll do this. We're going to do it differently. Excuse me? Nope. We're going back to the leak code that we did last class. Okay, so we got. Let me just make sure. Oh, you had all sorts of funky things in here. Okay, head equals temp.next. Head.next equals. Oh, that's what it was. Okay. Temp.next equals head.next. Okay. Head.next.next equals temp. Head equals head.next.next. Okay, cool. Let me just make sure we've got that all straight. Okay, this is what we ended up with last class. I'm going to recapture the board just because I couldn't remember what we had. Hey.
Sorry, I was taking a test for my Spanish teacher.
Okay. We're looping back to Daniel to this swap nodes in pairs because we didn't actually finish it up, and I know I jumped ship on it because I wanted to make sure we talked about the project. We're gonna cover the project, but I just wanted to come back to this for a minute first. All right. So if we look at this thing, we can do this a couple different ways. First, we can debug it and just see where we're running into problems. Okay, and I highly recommend you drop all of this into IntelliJ. So I skip over that. I step into our nodes. Okay, so let's look at this thing. We've got 1, 2, 3, 4, 5. And again, we already knew that the first part of this thing works. Okay, so I create a new Sentinel node. Everyone clear on why I create the Sentinel node? Why do I create the Sentinel node?
So you don't lose any part of the list.
Yeah, right? And you could almost think of this as like, I don't know how far I want to go with analogies, but you could think of this like your Sentinel node, we're building a dock, right? And we're throwing a rope to the boats, right? And now what we want to do is the first 2 boats are going to switch, and then the next 2 boats are going to switch, right? But we have to keep lines to each of those boats so we don't lose any of them to the sea. So I kind of like this analogy. Okay? So what's that? The dock stays there, right? We can't move the dock. We want that Sentinel to stay there, and we want to be able to keep the dock as our attachment point. Okay? So that's the first thing we do is we create the sentinel node. That's going to weirdly end up over here. I wish I could rearrange the visualization on this. My sentinel node points to where I want it to point to. Remember, I put it at head.next. So it's pointing at 2 where it already wants to point. Head.next here, I want 1 to point to 3, right? Because I want it to skip over. So that looks good. And then sentinel dot next. This points at 4 right now, but I don't want 3 to point at 4. Right? What do I want it to point at?
At 1.
I want it to point at 1. Right? So sentinel dot next is pointing at 1, 1's pointing at 3. So now I have sentinel dot next is 1. Here's my sentinel. I've got 2, 1, and then 3 and 4. So 2 and 1 have switched. So like so far so good. And now I just need to deal with the rest of this thing, 3, 4, 5, or however long it is. Okay? So while head.next, I got to think about that for a second. Do we even need the head.next does not equal null? Probably, right? If this were just 2 things long, if I were done, then I'd want it to skip out of this thing, right? Just trying to think if we could get rid of that condition. But okay, so while I have head, now head's pointing at 1, so it's if we draw up here, head is pointing at 1, right? So head's here, sentinel's pointing at this, 2's pointing at 1, so this is all good up to here. And then I'm going to say, okay, well, head.next, right now this is pointing here, and head.next are not null, keep going. Okay. Now, here's where we run into trouble. Temp equals head.next. So I set this equal to temp. Yeah? Let's just double check that I'm on the board here. I should, kind of pacing back and forth, but whatever. I should have put this up on this board. Okay, so now I've got temp. It's equal to the value at 3. We're good. Temp.next equals head.next. Temp.next equals head.next. I just pointed this thing at itself. That's a screw up. Okay? Because temp.next, 3 pointing at 4, I'm taking the pointer from 3 to 4, and I'm looping it back to head. I'm putting it at itself, and I just lost the end of the list, and I've got a circular argument. That doesn't work. So what do I have to do here? That line of code doesn't work. Temp.next, this pointer points at head.next. Well, now it's just pointing at the same thing it's already pointing at. I didn't move that pointer at all. Are we good with that? What if I start with head? Where do I want 1 to be pointing?
To 4.
So what is that? Temp.next. So head.next equals temp.next. Because I want this pointer not to be there, but pointing it there. Did I lose anything in doing that?
No.
Why not? What is the possibility that I lost? What's the one thing I possibly lost?
Like head.
I couldn't lose head. I got a pointer at head. I could have lost temp, but how come I didn't lose temp? Because I've got temp. Like that's the pointer at that thing, right? So I'm not going to lose it. So instead of this line, we're going to do head.next equals temp.next. Okay. Once we've got that pointer, where do we want 3 to point? Remember, what we're trying to do is swap these 2 things. We want 1 to point at 4, and then what's the next thing that we want to have happen?
Point to 3.
We want 4 to point at 3. What's 4?
Head.next.
I have 2 ways of, so it's head.next equals Okay, let's try that. I think I screwed something up. So wait, head dot, which line of code did I need to get rid of? This one?
Yeah.
All right, and then we said what?
Head dot next equals 10.
No, try again. Head dot, because head dot next is 4. Head dot next. Head dot next is 4. So I want head dot next to be. No, I don't want head dot next to be pointing 3. That would point this to here again.
Oh, right.
Head. We can think of this as next. Head dot next equals 10. Which I've got right here.
Yep.
And now are you missing anything? Oh, one last thing, I think, right? Because we've done this where 1's pointing at 4, 4 is pointing at 3, because head dot next is pointing at 3. That's the last thing I need to do.
We need points at 5.
I need what to point at 5?
10 to point at 5.
Temp, so temp, I'm not doing this linearly, sorry, so this is like 1, 2, temp, dot next,
Equals temp dot next dot next. Oh,
Next equals 10.
no.
so we've done away with that pointer, right? Because head dot next is temp. Uh-oh. Did I lose 5?
Yeah.
Yeah, I lost 5. Right? All right, so let's back up a step here. Let's get rid of it all. Okay. 1 points at 3. Okay, this becomes temp. Right? So let's think about this for a second. We've got head dot next. Where do we want this to point? Temp dot next. So far, so good, right? Yes or no? Okay. Now, how do I not lose this? Because I'm trying to switch these two nodes. So 1's going to point at 4, 4's going to point at 3, 3's going to point at 5.
We have to use a temporary node to score 5.
We could do that, but we don't have to. We can just switch the way in which we just did what we just did. Right? Because what do I want 3 to point at? I haven't lost a pointer to 5 yet. I want 4 to point at 3, but when I did that first, I lost the pointer. I lost this pointer. What can I do right now?
3.5.
Yes, do the 3 pointer to 5 first. So how do I point 3 at 5? Well, I know the pointer from 3 is what?
From 3.
Temp. Go ahead. What's the pointer from temp? Temp dot. Well, temp dot next is the pointer, and what do I want it to point at?
At 5.
Which is? Now that pointer is pointing at 5. I didn't lose 5 anymore. Do I still have track of everything?
Yeah, and now you point.
Now I point 4 at 3. So it's the same line of code. We just reordered these two things. So now head dot next. Well, head dot next dot next
equals temp.
temp.
That's cool.
All right. Okay. And this is where drawing it out on the board, like Again, here, you want to see my squiggles? I'll show you my squiggles in a
I
second.
feel like drawing it out makes it much more sense. Like, so
Yeah.
That's the point.
It's impossible to do it without drawing that.
To make a pointer from 3 to 5 so we don't lose 5.
Correct.
in movement. So-
Correct. Yep. Because if I do this differently, I lose. Well, first of all, we knew this didn't work because this was just circular. But what I had here, you'll see if I just do this. So head.next equals temp.next. We got that. Temp.next equals temp.next.next. Head.next.next equals temp. And then I just move head over. Head equals head.next.next. Right? Because I just take the head over, I move it over 2, and I just restart this process again. Does that make sense? Cool, let's try and run it. And if I run this thing, it doesn't crash on me. Now, I don't have a print statement in here because I just didn't load one in here. But if I visualize this thing and I step into it, oh, damn, I went too far. Hang on. I went one too many steps. All right, let's try that again. Boom, boom. All right, now I need to go through this. Okay, well, so right now, after the first chunk of code, I've got my Sentinel node. It points to 2. It points to 1. What we ultimately want to have, right, I'll leave this up here as a visual, is I want Sentinel pointing to 2, pointing to 1, pointing to what? 4, pointing to 3, pointing to 5. That's what we're looking for here, right? That swaps the nodes.
Oh, yeah.
So I've swapped the first 2 nodes here. I know it's a little hard to see, but I've got my Sentinel pointing at 2. That points at 1. 1 points at 3. Okay, so now we got to swap 3 and 4. So I come in and I do temp. I just added a temp variable there. Can't really see it. Okay, temp. Right, temp points at this thing, which is head.next. Head.next is going to point to temp.next. Okay. So now 1 is pointing at 4. Good. 4 is pointing at 5, so we haven't made that switch yet. So our next step, now I've got 1 pointing at 4. 4 still points at 5. There we go. 1. So Sentinel points at 2. 2 points at 1. 1 points at 4. 4 points at 3. 3 points at 5. We get up to our while statement. While head.next.next equals null, that's false. We're out of our while statement. We're done. What now? And the trick is then what are we returning? Sentinel.next. We don't want to return Sentinel because remember Sentinel's the doc. We don't want to give any docs back. We just want to give boats. So whatever the doc's attached to, whatever's the first boat attached to the doc, that's what we're returning. This is Sentinel, because I got the -1 in there. I'd love to put it, maybe I put in some bigger number, -1001, just to make it clearer. It'd be fun if we could come up with, like, what's a number that looks like S? S, what, 5, 3, there's no N. I was trying to come up with, like, you know what I mean? Like, can't do it. Yeah.
Is Sentinel not just...
Yep.
But if we're just returning 2, it's not going to return.
No, dude.
It's a recursive data structure. If I return the first node, what happens?
You return the next one?
You return all of
I return all of them because they're attached to each other. They're boats. Think about this. No, I'm so happy with my analogy. Right? I'm the doc. I'm sitting here. I'm a doc. Right? And I throw a line to you. You throw a line to Don. Don throws a line to Lloyd. Right? Okay. Now I hand this rope off to Gordon. What did I just hand off to him?
all for you.
The link through you. Even though it's just the rope to you, you're attached. They're attached to you.
Oh, okay. Okay, yeah.
When I run this, I lose the pointer to...
If you keep going, yes, you do. But it's correct. It's for some reason the visualizer is doing this weird thing where it's chopping off the end.
And then
But if you actually go one more step into it, go one more step. Just hit this step over one more time.
What are you returning?
I have like in my main list nodes we have in.
Well, I'll tell you what, to confirm, drop it into this and just see if it works, which it does. This should be the exact code. Sentinel, head.next, this is all the same code. This should look exactly the same. So temp equals head.next, head.next equals temp.next, temp.next equals temp.next, head.next equals temp, head equals head.next.next. And again, if you read this and didn't have if I read this and didn't have a picture to look at, I'd be like, what? Next.next.next, no idea. Yeah. Okay, who solved this recursively? Did anyone that's here solve this recursively? I'm just going to show you the recursives, and I have to make all these people absent because they're absent. Yeah, there we go.
So basically, the pointers, if you find all of the like, which one, like the return, when you return the linked list.
Yep.
The order of the pointers is the order of the nodes that you're returning.
Yes. Yep. Because they're all it's just the pointer to the next thing in the line. And if I submit this, this is the exact code, Daniel, we did. And if I submit this, we get it accepted. And if I click on details, it's not bad. It's an iterative version, but we beat 70% of Java submissions with memory usage, and it happens in 0 milliseconds. So there's no time comparisons here, and we passed 55 cases. Okay. There are there's probably, again, the beautiful thing about computer science is there's tons of different ways to solve this, right? If you notice in my earlier version of this, and some of you wrote down a few parts of this, I threw in another node and used that throughout this. That worked fine too. So you could have another pointer in there somewhere to help you do some of these swaps without, I didn't use head at all. I did, sort of. But you can throw in another pointer in there if you want to, if it's helpful. And then there's the recursive methods. And this is where these become kind of funky. So this is sort of the easy recursive method, which is the exact same if statement, right? If head equals null or head.next equals null, return head. We sort of have to do that regardless. We make a new head node, and it's head.next. And if we look at our iterative code, we sort of do that with our Sentinel node. Okay? Then we make another temp node, which is head.next.next. And then we swap pairs at the bottom of this thing. So do we actually even want to try to do this on the board? Or do we want to spend our time working on our project? You guys want to see the recursive method here?
Yes.
Yes.
Really? You sure?
Yeah.
Yes.
But we're good with this. Iterative method makes sense. Okay. Let's see if we can make sense of this thing. All right. 1, 2, 3, 4, 5. Okay. So we make a new list node, which is new head. And where does new head get pointed to? Yeah, so we have a head, right? That's head. And we get new head. I'm going to use shorthand because I'm tired of writing. Right. And then I get a temp, which is head.next.next. So I've got 3 pointers here ostensibly, right? New head dot next equals head. So I'm saying this, pointing this way. Now, why didn't I lose 3? Because I've got a holder for the rest of the list.
New head.next goes backwards to head.
Yep. Because remember, I want to switch 2 to. I want to do that. I want to switch 2 and 1. So ultimately, I want 2 to be pointing at 1.
How does it go back?
Because I'm just saying, hey, this pointer goes back this way.
You're saying the node after you had is equal to the one before, like equal to head.
Yeah, I'm still saying head.next is new head, and now this is circular right now. Okay. Head.next, so this pointer, okay, becomes the recursive calls to swap pairs on temp. And now I pass temp into this thing, and I just keep doing the same thing. Now 2 is pointing at 1, 1 is pointing at 3, right? What's that?
When you're passing temp in, though, what's that do?
So when I pass temp in, it just does all those same things again. I pass in temp, right? Now I do have to create a new, and this is where the recursive stack becomes really confusing, okay? So think about this, what am I returning? New head, but we can see, if we just think, I don't want to go through all the steps because we're going to lose track of things here. But new head, if I return this, 2 is what I want to return, right? Yep. 2 points at 1, 1 points at this end over here, right? And when I recursively call it, those pointers are all going to happen again. So what's going to happen is, if I think about it, right, the first step that happened was I get,
Points at 3.
what's up?
4 points at 3.
4 points at 3,
3 points at 5.
3 points at 5, and then I get a recursive call out here. Well, in this case it's finished, but if it were longer, it would just keep going down 2 at a time.
Because head.next. Oh, wait, no.
Because I'm still, no, head.next doesn't, yeah, it's a little confusing. This creates a recursive stack. This is where it gets really confusing. Because would I be doing all these same steps down here? Yes. But when I come back up, remember I'm backtracking up the recursive stack. So this is the last head.next, right? Or new head, sorry, this is the last new head. So I'm going to have a whole bunch of new heads down here because I'm doing it recursively. But this is the last one on the stack, so this is what I'll return. Yeah.
If you're going back up the stack, wouldn't it be like backwards though? Like 5, there would be 5, 3, 4.
No, because I'm returning each new head. They're all chained this direction, but I'm returning them this way. But they're chained this way. I'm not changing the direction of the chains. I'm just returning them this way.
Yeah. So because you have the existing pointers, when you make a recursive call and it returns backwards, everything stays in head.
Yeah. Now, if you really want to get confused, this is the really shorthand way of doing it. Same if statement. I create this. We'll try this. We'll try 3 ones. And this is where, I'll be honest, this is where recursion gets like sort of silly ridiculous. Okay. So I've got head. Right? I create a node that's head.next. Okay, X. Head.next is equal to the swap pairs on head.next.next. Right? So head.next, it points at head.next on that call. Right? And then x.next equals head. So it's sort of the same steps, but the recursive call is in the middle of this thing. And it just, in my mind, the recursive call in the middle just makes it really confusing, right? Because when I hit that, what I'm actually doing is I have to do the recursion all the way down the line, because the recursive stack happens in the middle of the call, and then those x.next equals head happens after the recursive calls. And that just gets really...
Oh, right, yeah, right. Because you're essentially, you keep doing that thing until you reach the end, and then you just, when you return X, it's like the first, it's the top of the recursive stack.
Yes.
Which, and then when you return every X, it just returns that.
Yes. You got it.
Oh, yeah.
Do we want to see one of those in action? Just to see what the recursive stack looks like?
Oh, you want X to be first.
Recursive swap pairs, I've got it in here. I put this one in with the recursive call in the middle. Do we want to see the other one, or do we want to see the one with the recursive call in the middle?
The one in the middle.
One in the middle? The more difficult one.
Would the one in the middle have the worst runtime because it has to go through it?
The recursive calls are probably going to be about the same. Yeah, because each of these steps afterward is just one step. So it's just the number of recursive calls. Yep.
So it returns X first if you're going down the stack. X is first, and then you go head, and then it goes from there.
Well, no. So with this one, if you think about what's happening in here, where'd it go? If you think about what's happening in here, we do all the recursive stacks, right? And then we do these x.next equals heads and returning x. So essentially all the recursive calls happen, and then we come back and we just say x.next equals head and keep doing that all the way up until we get to that last x and we return that. Let's see if we can visualize it and see if it makes any sense whatsoever. Yeah, so this is this will thankfully only have 2 recursive calls in it. Okay, so we're going to step over that. We're going to step into this. So we're going to call recursive swap. We've got our if statement. Great. We create a new node. It's just pointing at the next thing. Head.next. So now this is going to point at a recursive call to 3. Because remember, I want to just skip every 2. It's more or less makes sense, right? Now x, so if we look at this now, 1 points at 4, points at 3, points at 5, and x is 2, which is what I want. Oh wait, did I just step all the way through it? No, I didn't. Because, oh wait, I did step all the way through it. Hang on. I didn't step back into, let me try that one more time. I didn't step back into the recursive stack. That's why. All right, so we got that. We got that. Okay, so right now, all we have is head pointing at 1, x pointing at 2. We get the recursive call on head.next. I'm going to step into that. Okay, head now is pointing at 3. Everything else is still the same. Nothing's changed. Right, head points at 3. I create... What the heck? That's not the right... Why did it just skip into a different method?
I think you called it swap pairs instead of recurse swap pairs.
Oh, did I? I think you're right. That would be a problem. Okay, let's see. Let's try that again. Yep, there we go. Good catch. Why did I go into a different... Let's try that. Okay. Woohoo. Thank you, Daniel. It's Friday afternoon. All right, step over, step into. Boom, boom. Okay, we're here. We're going to get a recursive call on... There we go. Okay, 1, 2, 3. We're going to do the exact same thing. So again, x is going to equal head.next, so that's going to point at 4. We get the recursive call on swap pairs that's going to just point at 5. And if we looked really carefully, we got 2 recursive calls here. We can see x and head. Remember, head was 1, x was 2, head was 3, x is 4. Now we're going to do this next recursive call, and we're going to point at 5. Now head is 5, x is... What's x going to be? Null, right? So now if head... dot next equals null, that's true, we're going to return the head. Right, so we return the head. What's the head? Just 5. Right, so that we just knocked the first piece off our recursive stack, the bottom layer off our recursive stack. Now we're working our way back up the recursive stack. And this one gives us, right, this one swaps those 2 things. Now 4 points at 5. Okay. Wait, that's what we wanted. That's still, wait, hang on for a second. 2, nothing's changed yet. Okay, there we go. 4 points at 3. That's what we wanted. 3 points at 5, because we just did the x.next, right? x.next equals head. So we pointed at the head, right? Now we're coming back up and just changing the pointers as we come back up. We come back to this one, right? Now we're here, and we're going to say x.next is going to point at head. So we've got 2 pointing at 3, pointing at 5. Oops, we lost our 4. That's interesting. I wonder if that's a true screw up. So x.next is going to go ahead, so 2 is going to point at 1. That should do the trick. Oh, 4 came back. There we go. Our visualizer is a little out of whack. So now 2 is pointing at 3. We want it to point at 1. Here's where we're going to rechange the pointer on 2. There we go. Okay, and we're essentially done. So now we're going to return x. X points at 2, 2 points at 1, 1 points at 4, 4 points at 3, 3 points at 5. Whew.
So it basically skips all that like head.next equals temp.next stuff we did by calling the recursive method on the head dot like 2 over.
Yep.
And then it just goes backwards and returns that.
You got it. So those 4 lines of code right there, well, it's essentially 3 lines of code, right? Because we sort of forget the if statement and the return statement. These 3 lines of code take the place of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines of code. And that's where recursion is like super clean and neat and super useful for, specifically, this is a recursive data structure, so it works really nicely. I don't expect you to be able to like, oh yeah, I could totally write that recursive, method to get this to work. But do we sort of understand the underpinnings of what's going on? Thumbs up, thumbs sideways, thumbs down. Okay, awesome. Okay, let's go ahead and break out your decks. And we're going to do a couple things to our decks. And then we're going to get out of here early. Oh, all right. So with your deck, I'm going to give you, if you go back into, ready, we're going to do something really quick. If you go back into our assignment, I changed things a little bit in the assignment. So what you're going to do is you're going to go to an assignment, copy and paste this entire box. Grab it, Control-C, copy it. Copy everything in this box. This is the way we're going to test your code. Well, one way we're going to test your code.
Oh, was the class called Deque or DL? Isn't it like a doubly linked list?
It is.
It's also a Deque.
It's also a deck.
Is it okay if I put DL?
Yes, which is kind of funny because I did the same thing. So doubly linked list, a double-ended queue. A queue is, what is a queue? Yeah, especially if you're from anywhere in Europe or anywhere else, right? A queue is a line, like you get in the queue to go get your lunch. And interesting, so this is actually a really important point because we'll talk about queues more. What's the key feature of a queue? Yep. You add to the end, so it's what's known as a FIFO. First in, first out. Right? So if you have little people walking into the lunch line, we're going this way for lunch. The first person in the line is the first person out of the line. Unless someone cuts you off. It happens in the lunch line. Right? So people add at the end and they come off the front. Okay? But this is a double-ended queue, so we can go either direction. It's kind of confusing. Adding to the middle is not what we want to do with a queue. What's that? Cutting doesn't work. No. So you can't cut these queues. These are ideal queues. You can't cut them. Okay? So what you're going to do is you're going to take everything I just gave you, and so I did this slightly differently than the way that Gordon did it. Gordon is just going to call this thing deck.java. So you're going to open up a new class. Okay? If you already have, if your class is called deck, just call this deck I. Deck with a big I, because it's our interface. And we haven't learned interfaces, but we're about to. You make a new class called deck I, or in Gordon's case, he's just going to call it deck. Did anyone else name this something other than deck? Okay. I called mine DL deck specifically so I could have my deck interface. And you're going to call this thing a public interface deck. or Deque. And you're just going to drop all this stuff in here. Just paste everything in and make sure you get your curly braces in the right place. And I just want to see if that works.
There's a reason why we're doing this.
Perfect. Yep. Public interface deck. Perfect. You always throw me off with your different screen. The way that it's set up, it makes it look like typically when I see colors like that, I've thrown an error. Okay, so here's what's cool. You're going to go over to your deck. This thing is an interface. So what do you notice that's a little bit weird about this first? So we got some T's in there. We're going to take care of those in the next couple of minutes. But what else do you notice that's really weird? Let's look at add first. What's weird about add first? It's grayed out. Okay, so we're going to deal with that piece. Let's look at public. Let's at size. What's weird about size? Come on. What is size? What is this thing? It's a method. What do we expect when we have a method? We expect some sort of code in there that is a method. And we'd expect, what else do we expect at the end of a method signature?
Curly brace.
Curly braces, not a semicolon. Oh, but don't do anything because this is correct. An interface says what this thing should do. Okay, the interface says, hey, we're going to implement this interface. You'd better have an add first, an add last, an is empty, a size, a print deck. We're going to have to do all those things. Okay? So we do this just this way. We just give the signature and we end it with a semicolon. Now you come over to your class and you say, public class Deque, or whatever you call this thing, implements Deque.
Like instead of extend.
Exactly. Extend. What is extends used for? Subclasses. Exactly. This is implementing an interface. We implement interfaces. It's very much like extends a subclass or a superclass. Okay. Now you might see this. Go ahead. That used to have interfaces. Yeah. So remember when we went through some of the old AP stuff, we saw interfaces. They used to cover this on the AP exam. They don't anymore. And you can sort of see why. Right? So I'm going to do this a little bit differently. Next time we come up against this, when we do our project 1B, this is the way you should approach it. Because all I have to do, everyone's eyes up here for a second, is instead of going through and adding all of my methods, I click on Implement Methods. It lists them all out. I click OK. Bam, they're all in there. You'll notice they're all overrides, okay, which I want. And now all of these things are in here, done properly, and now I just have to add them in here. If you did not get code for all of these things, your class will now throw an error. Yes? Okay, so you can see which methods you have problems with. I've got problems with, that's kind of weird that I've got just problems with these three things. Have an awesome time. Good luck. You're going to want to catch the end of the video on this thing. I'll send me an email. I'll try and remember to send it to you. But yeah. You do not have to put this add override. We'll talk about what that does and what it doesn't do. We don't need to worry about it quite right now.
We should hover over and press implement.
Don't do what because I'm assuming, did you already add in the methods?
Like
In your in your deck.
Yeah.
Yeah, you got them in there, right? Don't do it again.
Oh yeah.
Because then you'll get them twice.
It's like saying you cannot find symbol class. That's next class.
Cannot find what?
Symbol
T. We're going to fix that right now.
Oh.
Okay. So I'm going to do this. Where am I going to do this? Let's look at it in paper form, and then we'll come back to it. Okay. So we've got our doubly linked lists. Generic lists. So what's our problem with our current int lists, singly list links, and deques? What's the problem with them? Can't add to the middle. That's sort of an inherent feature of them. They only can take ints. What if I want to do strings? I have to completely copy the class, right? Recreate the class and do it for strings. Is that a great idea? Yeah, not so hot, right? I don't want to have to create something for, and then if I create my own class, chimpanzees, I'm going to have to go implement this class for chimpanzees. So instead, we make them generic. That's what the T is. Okay? Okay, so we can only support integers. This allows us, okay, generic types allow us to defer type selection until declaration. What does that mean? How can I simply show this? I can't simply show it, so we're not going to. But what I'm going to do is I'm going to say, hey, my deque takes T's, okay? I can do this however I want to, okay? But what my public class list is going to take into it is T's as opposed to something else, okay? And now when I do, these are both void methods. Don't worry about that. Size, print deque. You'll notice that I have all of these things already say T in them. What you can do is if you had public int remove first, you can do this fun thing. You can go to edit, copy, where's find replace, and anytime you have, you have to be a little careful with ints because you might override it. So actually, we probably shouldn't do it that way. How do I get rid of the find? Where? No, definitely no. There we go. There's my X. Whew. Okay. If you wanted to find and replace, but I realize that's not going to be a great idea because we're going to have other ints in here, so we don't want to do that. All right. But if I do this, and I could call this whatever I wanted to, right? He does this. He does these bleep blorps, right? I could call this whatever I want to. This generic type, as long as every time I go in and do this, I'm making it an item, right? So if I come in and I, where are my other projects? S-list, where, S-list 20. Why'd that go so far down here? Okay. If I come here and I grab my int node class, right? Because do I still need my int node class? Yeah. I do for my deque, right? But now we're going to drop this in right up here. It's no longer, we're going to say, because is it an int node? No, it's a node. And instead of taking int items, we're going to take T items. And these are going to be nodes. So now here, I will use find replace. So find, replace. Anytime I have int node, I'm just going to replace it with node. Replace all. Isn't that so nice? So now I have a public node. What do I have to do with my node class? T item and node. Wow, why did that disappear? Oh, because I started doing it. Remember, if I'm doing a circularly linked list, what do you guys have to do with your deque in your node class? Node previous, prev. Okay, and here I'm going to say, now here, do I want to int I in my constructor? I want a ti. Funny. A node next, a node p. Item equals I, that's fine. Previous equals p. And then the rest of my code's going to be fine because of the way I did it. Sorry. But you want to go through and see your add first is adding a t item. Your add last is adding a t item. Size is still an int, right? Print deque is fine. Public t remove first. Public t remove last. Public t get. That will be an int index, so that's why we didn't want to replace ints. And now, as I go through, I can make this a generic type. So now, what it's saying here is that I'll defer type selection until declaration. Well, you've already seen this. Alex, real quickly, where have you already seen this? On the AP. Where have we seen generic types? Remember, they're in these little brackets like this.
Array list.
Array list, you got it. Array list, well, the way array list is written in Java is array list T. T for type. You can use whatever variable you want to as long as you're consistent. I'm going to use T for type for right now, okay? So T for type, and then when I go declare an array list, what do I have to say? When I make an array list?
Array list equals new array list.
String.
String. I have to pass something. I don't say T. I pass in the actual object that I'm going to use. It transfers that into every piece of the code. So now I've got one array list. It applies to any type that I pass in there, any reference type I pass in there. So making all of our code generic allows us to pass in whatever type we want to. So our Deque is going to be able to take strings, integers, doubles, theoretically booleans, dogs, cats, you name it. Have a good time.
Great. Thank you.
Yep. Catch the rest of it.
Polymorphism, right?
It is a form of polymorphism. Yep. Yep. Exactly.
Can I do action off Monday so just go over the last part of the class?
Yep. And you email me for the video too.
Okay, cool. Thank you.
Yep. Does that make some level of sense, right? So now when I do slist, I can pass in an integer, and I can insert in the front 10. If I pass in strings, I can insert in front of the apple.
It still has to be like a valid type.
When I declare it, Deque has to be integer. It has to be a reference type. I can't say Deque and then pass an int here. So the angle braces, right? Whatever's in there has to be a reference type. It has to be a class. Yep. And that's it, honestly. Okay. What is this? Int node. We've got our int nodes. We're going to spend a lot of time on generic types, but that's basically it. So that's why we have the T type in here. So Deque T. Now let's hover over and see what I've got. Must be declared abstract or implement abstract. Right. So until I implement all of my methods, this is going to give me trouble for this thing. Okay, which I haven't done obviously. So, but what I can do, just so you know, if you're like, hey, I'm really struggling with print Deque. I can't figure out how to get print Deque to work right now. Okay, you can do one of two things, but the easy thing to do right now is just comment out print Deque from your interface. Matter of fact, I'm going to comment out all of these things just for right now. So we're going to get rid of everything except for add first. And we're going to implement add first. So we're going to come back over to the Deque because I haven't implemented anything. So add first, I don't need to worry about any of my, yeah, I do. I've got to get rid of all these things too. This is the only problem with doing it the way I showed you, because you have to actually implement everything. But if I do that, I can now go in and just add one method at a time, which is the way you should do this. So what do I have to do first? What's the first thing I should do here in my Deque? Okay. And how many constructors am I going to need in here? So what do we should have? Public. So public DL Deque. So here's one trick to this thing. Okay, I'm going to pass in. So I want one that's empty constructor. Okay, and I want one public DL. Oops, no, DL Deque that takes in how many parameters? Just the TI? Okay. With just one thing in it. Do I want pointers?
Yeah.
So do I want to pass in the pointers in this thing, or do I just default the pointers?
Maybe create your sentinel inside the constructor. Like, can you say, Sentinel. You just create a Sentinel node.
Where should my Sentinel node exist? And if I look, I can come back to, and I highly recommend you do come back over here and look at the way you built your S list.
Right. The way we build our S list is we build the Sentinel inside the constructor.
We initialized the Sentinel.
Yeah.
We declared it outside. So we're going to have instance variables. So we're going to have, what type of thing is Sentinel now?
A T.
What is it?
Oh, it's a node.
It's a node. It's a private. We want. What did I just do? Okay, it's a private node. Sentinel. I'm still gonna call it Sentinel.
And we need a size.
And we need a private in size. That's all we need. Okay. Now inside my constructor. Now Gordon's quite right. I can finish this thing out. So Sentinel equals new node, yes? And what do I want to pass into my node? Well, now I got to be careful. So I put in, the way you do your constructor, the way you build your constructor here is actually kind of important, your node constructor. Why? What's a sort of intuitive way of building this thing? I mean, you could put whatever your item is first, and then your node next, and then your node previous. I kind of feel like if I visualize it, I'm sort of going to visualize it as a node previous, then the item, then the node next. Does that make sense? It doesn't matter, but when I'm building a node, I'm thinking previous item next, because that's just, I use the visualization of, if I come back up here, I'm using this visualization, previous item next, this little 3-box thing. It's just what it sticks in my head. So that's the way I'm going to do my constructor. So I am going to do, what did we say, Gordon, null. I'm going to do like negative 10,001. I don't know why, but that's what I'm going to do. And null. Size. Size equals 0. We just want the Sentinel node. And then when I create one item, Sentinel equals new node. What am I passing in here? What do I want to do with this constructor? What is previous gonna? Well, I got to think about how did I do it in my S list when I did this. Okay, I created the Sentinel with -1 and null, and then I did a new next and put that in there, right? So,
You create a new node with the item X, and you say that Sentinel dot next equals that node. And
so do I need to create Sentinel in the exact same way I did right here? Yeah, so the Sentinel call should be exactly the same. Null, negative 10,001, null. And then I can do, I just got to think about this, Sentinel, what? Dot next, yeah, equals. Now here's where I got to think a little harder. What's my previous Sentinel? My value is just I. I'm passing in I, whatever that T is, thing is, right? And what's my next? Sentinel. It's circular. All right. I've got my constructors. I should probably test my constructors. But let's just go ahead and let's run with it. Let's see if we can add first. We got 10 minutes, 9 minutes. How do I add first to this thing now? Yep.
You need to initialize Sentinel.previous.
What do we think? Do I have to initialize Sentinel.previous?
Yes, because you have to go back.
Okay, Sentinel.previous equals what?
Oh, sentinel.next.
If it's circular. Okay, let's think about it. Oh, brain breaking. It's Friday afternoon. I want to go home. Okay. All right. Let's think about this thing. We've created a sentinel. Yeah. Okay. And this is just empty. We'll call this like 10,001, right? Whatever we call this thing. It's got no pointers right now. No, all good. And then we create the sentinel.next pointer. We said it's 1, whatever it is, okay? And its previous is sentinel, and its next is sentinel. So where do I want this pointer to go? Right now, sentinel has a previous pointer, and it's pointing to null.
I wanted to point to sentinel.next.
I want it to point. Well, I can call this a couple different things, but I want this pointer. I want everything to be circular. So sentinel.previous
equals sentinel.next.
equals sentinel.next.
And for the empty constructor, it's just sentinel.previous equals sentinel. We don't have like.
Do we have to declare, or can we just leave these null? Do we want to, I mean, we could have this pointing at sentinel and this pointing at sentinel, yeah?
Right.
So we never deal with nulls at all?
Yeah.
Okay.
What if you want to know?
What do you mean if you want a null?
Like if you have a list and, or like what if we have a problem with the deck and one of the values is null? Like want to just.
Can we have a deck that has a null value?
No, we can't.
Yeah, there will never be a null value. So let's now I'm going to put in a one more class. I'm going to put in a Java class. I'm going to put in a deck runner. I don't know why that sounds fun, but a deck runner. And deck runner is just going to have a main method in it. We're going to create a DL. Let's just do an empty one, and then we'll do another DL deck. Deck2 equals new. And we'll pass in 10. Now, it's not going to like this right now. Right? It's going to say, hey, raw use of parameter as type. I got to think about what I've screwed up here. Because we didn't tell. What do we have to do with deck runner? We can't do just DL deck. What do we have to do? What do we have to do with an array list?
Oh, the type.
Yeah, we have to tell it that we're going to put in integers. And then these little things go away. The kind of fun thing is, and we saw this with our array lists, do I have to pass in integer over here too, on this side of the equation?
No.
Nope, I don't. I can just put in the brackets. Bam! And I'm just going to throw in a red dot to debug this thing and just see what I get out of this thing and make sure it's running. Okay, T reference cannot be referenced from a static context. Shouldn't be a problem. Let's get rid of static. Why is that problematic? Deck runner for a second. Cannot find symbol T. Oh, deck. T, one related problem. I did implement that class. right? Or did I just screw something up when I did that? Oh, where'd my add first go? Didn't I have add first here just a second ago?
Yeah.
Oh, wow, that stinks. Okay, I'm going to have to rewrite add first. Oh, no, I didn't. I never put add first in. What, right? We didn't finish add first. Okay, we're going to leave it at that. I want you to get a sense of that piece, and then what we'll do is we're going to slow down a little bit, especially because only half of you are here. And we're going to do the same thing, just so you know. We're going to do the same deck for Project 1B with an array list underneath it. Sorry, with an array-backed deck. Okay? But for right now, I just want you to have a sense of this, and we'll clean up the problems with making it generic and passing in the generic type. So I know there's probably some questions right now. I didn't get through as much as I wanted to today, but we'll clean those up for next class. Yeah, anyway.
So I spent like 2 hours trying to figure out the deck thing,
Mm-hmm.
and I did so without implementing the int node thing at all.
Okay.
So when we create the deck class,
Yep.
we have to. We have to structure like the SL list thing we did because they're both lists that implement the nodes.
Yeah, so you have to have an internal node class.
Okay.
Sorry you got so hung up on that. But you do have to have this node class with the previous and the next.
Okay, that makes sense.
Okay.
I spent 2 hours, but I kept just writing not random code, but like trying to figure out how to do everything. But I forgot to implement
The node class, yeah. So spend maybe a little time before next class seeing if this helps you get through some of those pieces. How far did people get with this?
I finished the printing tab.
Oh, so you're most of the way through it.
Yeah.
Okay.
I shall have to-
And you guys are previous to work. Have you tested it at all yet?
No, but
Okay.
they work in my brain.
It worked. That's fair. How far did you get? Yeah.
I didn't do the previous one. I just did like the loop.
How'd you do it with the loop if you don't have previous?
It's like I have a send back and send forward.
So it is sort of previous and yeah or no?
But it doesn't have the previous. Just
Well, but what's your sent front and sent back?
like one pointing at the front and one pointing at the back.
What about each node? Does each node have a pointer front and back?
No.
Okay, just the sentinel does.
Yeah.
Okay. So that piece
I
we
was
can
like
think about.
very confused about this.
Okay, fair. If you guys are like, I didn't realize just how disjointed my directions were. Where are we?
I got like all with two.
Why would you do that? Don't spend 5 hours on your homework. Holy cow!
I didn't really get through much of it.
Okay. All right. Here's the deal. We're gonna sort of regroup. If you struggle with, if we didn't have the nodes, try that. You do need to have Donald. You do need to have your nodes have previous and back because that's the whole point of a doubly linked list, right? Is that each node can point at the thing on either side of it. Okay. And then Logan, did you have both the node and your previous? It looked like you had previous and next pointers.
I did.
That's totally fine. So we're going to make it generic, but don't worry, like you've done enough for next class. What?
I did not make it generic.
Right. We'll take care of that for next class, during next class. Okay. Sorry, and I kept you over. I was planning on letting you guys go early. So have an awesome weekend, everybody, and yeah, enjoy. Get some rest. Yep.
Should I try to work through this and resubmit it on Canvas, or?
That's fine. Yep, I will. Yeah, you should be able to resubmit it.